Hello everyone, I thought I would put together this video to help you through some of the problem solving process improvement tools that we will be using in this course. Hopefully this helps you out. I've got a number of links out there which may also help you as you work forward. All right, so first this comes from Peter Drucker. That which gets measured gets improved. A lot of process improvement, a lot of problem solving is really based around metrics, measurables, key performance indicators, whatever you want to call them, whatever your organization calls them, they all mean the same thing. We have to have some sort of measuring stick, some sort of number, something to tell us whether we're doing things correctly. So first, we're going to talk through the PDCA or PDSA cycle. So there are 4 steps. PDCA and PDSA are much the same, just really a difference in semantics. PDCA is the original one. PDSA is a little easier to teach, so I oftentimes talk about that one. But let's just talk through the steps. All right, first, our plan. So the plan step, the first step we do, we clarify and define our problem. We write our problem statement. We develop our measurables. We develop our key performance indicators or indices, our metrics, whatever we're calling those. We do our 5 why, our root cause analysis, and we develop our countermeasures. So first we identify that problem. I've got some other materials out there on developing a problem statement. We want to focus that problem statement on exactly what is the problem. We're not solving it at this point. We're simply stating the problem, when and where it occurs, what the magnitude of the effect is, those kinds of things. We're not placing blame. We're simply stating what the problem is. So once we've got that, then we can proceed with the rest of this. So we need to talk a little bit about the 5 why and the Ishikawa or the fishbone diagram. So once we get our good problem statement written, it goes on the head of our fish here. Once we have got that in place, we clearly defined our problem, we start going through what are commonly called the 6 M's. So the first M is machine. So what problems with a machine caused our issues? Was something out of adjustment? Do we simply have the wrong machine? Is it in need of maintenance? What is it? Next one is material. So what sort of material problems do we have? Is our raw material coming in outside of our specifications? Did we change materials? Was someone selecting the wrong material to enter our process? Was the material itself too hot, too cold? Those sorts of things. Measurement. Measurement is the when and where and how of how we're measuring. So if we are measuring say a piece of metal to cut it, and is cold outside, and so that metal is smaller, so we cut that metal and then we try and feed it into our process in a hot room, that metal expands and it caused some sort of an issue, whether it's with the machine or whether it's simply too long for our specification. Maybe we're using the wrong tools to measure. Maybe we're measuring in the wrong time in our process, those sorts of things. Next one is manpower, sometimes called people. So anything to do with the humans involved in this. Is there a lack of training? Did we have someone was out sick? We have a new employee? Anything related to the humans in the process. Next is our method. This is the hows of what we do things. So what are our processes and procedures? What are our SOPs? Do we not have them? Not having them is also a method. And lastly is Mother Nature, sometimes called environment. So this is things like humidity, heat, temperature. This can be something is stored outside versus inside. And as you see, there's a lot of things that can go in a lot of different bins. It doesn't matter which bin it fits in, as long as it fits inside of a bin. So an employee being incorrectly trained on measuring could be the method of training. It could be a manpower issue because it's training, or it could be a measurement issue because of how that employee is trained to measure. It doesn't matter which bin it goes in, as long as it's captured in a bin. All right, next we're going to talk about 5 why. So 5 why is also used alongside of our fishbone diagram. We ask why 5 times, or The other way I like to explain this is you ask why like you are 5 years old. So if you just think about a 5-year-old asking why until you can no longer explain what deep questions they have about the meaning of life, you have probably reached your root cause analysis. So the 5 why is also called an RCA, or root cause analysis. And then we'll bring this chart back up. You'll see that a 5 why fits within that. So if we have a method, once we've determined our method issue, let's say we're going to chase the 5 why down that leg for a while. So we might find a why there, and then when we ask why again, we get that. We ask why again. We ask why a couple more times. And this keeps branching deeper and deeper and deeper. 5 why works really well on a giant sheet of paper or a giant dry erase board in a meeting room. Sometimes these can really get marked up with a lot of little scribbles, notes, stickies, that kind of thing. That's how I prefer to work on them. All right, so we've done all of this planning, and we've got to our root cause, and now we're going to do something, right? We've developed our plan, we have our countermeasures, and we're going to simply do it. That's it. We're going to implement our plan. This is the simplest step, but also oftentimes the most work. Then we're going to move to the check or study. So in this example, we're evaluating our results. So we look again at our KPIs, our metrics, measurables, whatever you're calling them, and we're looking for second order effects, also called unintended consequences. So we look for anything that we didn't realize that this is causing an issue further down the line, further up the line. Another department in our company needed that piece of information, whatever that is, right? So once we've done this, we've decided, are we meeting our goals? Did we get what we wanted out of it? So if we did, we act or adjust either way based on whether we're happy with our outcomes. So if we succeeded, then we standardize and we celebrate our success, right? This is a good time to get a pizza party together. This is a good time to create our standard operating procedures. We have saved money, we've increased productivity, we've reduced overtime, whatever it is, right? But maybe it fails, and it fails a lot. So we're going to learn from that failure. So what is our next plan? So we're going to go back and we're going to start in the plan step all over again. Or even if we didn't fail, we're going to create a new target or goal to run through CA PDSA again. All right, so that's our introduction. Now we're going to PDS our way to perfect toast. So I'll run through an example of how this would work. So our plan is we want perfect toast. We're going to create a measurable. Well, how do we measure perfect toast? Sometimes these are difficult to come up with. Here it is. We've come up with a color scale for perfect toast. So we're going to create a problem statement. So the last piece of toast we made was a 9. We desire to have toast at 4. So in this, you can see we're talking about future and current state. So future state, toast is at a 4. The last piece of toast was at a 9. That's our current state. So there we go. We've got a pretty simple but effective problem statement. So let's move forward. Let's do a root cause analysis. So we have our fishbone diagram again. So we have our problem statement. So our measurement, we have what measurement issues contributed to our problem. We have no markings for toast scale. Okay, so that's an issue. We don't know what markings relate to what actual output. Material. So are we talking bread? Are we talking whole wheat or white bread? Are we talking a bagel, English muffin? Right? All sorts of changes in material there that can cause problems with our output. Machine. The toaster has numbers versus a pictogram of toast. So here you can see that machine and measurement, we could say these are about the same thing. It doesn't matter. We could put this actually in either bin. It doesn't matter, right? As long as we're capturing that. Manpower. The last user wanted toast darker. Okay, so we have a roommate. They wanted toast darker than we had it, than we want it. So the setting was different. Method. We did not check the settings before we pushed the toast down. So we're not checking our settings. We should be doing that every time we set up any machine, right? So we simply did not do that. Lastly, Mother Nature. Bread sometimes comes out of the freezer before going into the toaster? Is the toast more stale, drier? Is it more moist, right? All these sorts of things you can see here. This could also be related to material, right? But we've kind of captured some of the ideas that might cause this. You are not limited to one, so you can have multiple different issues listed within measurement, within material, etc. You might only have one, and you might not have something in every bin. This is simply a framework to start gathering to ensure that we're being very complete on all of the possible issues. Okay, now let's 5Y our way down. So we have rejected toast. Why was it rejected? The toast was too dark. Why was it too dark? Because the toast was down too long. Why was it down too long? Because the setting was incorrect. Why was the setting incorrect? Because the roommates liked the toast darker, the last person to use the toaster had a bagel, and we don't know what setting to use. So at this point, we need to talk about causal versus contributing factors. Causal factors cause the problem. All right, so if we eliminate all of our causal factors, the problem goes away. Contributing factors will contribute, but not necessarily cause. So if we eliminate contributing factors, we can reduce the chances of the issue, but it's not likely to eliminate the issue. The causal factors, elimination of this factor will greatly reduce or eliminate the issues. All right, and then because we think these are contributing factors, right, if just there's nothing we can do about them or they're very difficult to address, we're going to go down a different leg here, so we don't know what setting to use. That's fairly easy to address. So we don't have a toast standard. Well, we need to create one. So our plan, we go ahead and we take a look. Our current state, the setting is all the way up and it produces a 9. Okay, so our plan, let's say, okay, there's 9 points on here, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. Right, so we're at 9. We think that maybe a 4 will produce a 4. We desire toast on a 4 scale. Action plan, we're going to adjust the setting to 4/9 of the scale. So at the do step, we're actually going to do that. There it is. We turned our knob down. So now we're going to toast, make some toast, right? Toast some bread, and then we'll see what happens. All right, now we evaluate our results. So we can see here that, okay, this came out. It's not really on our scale, right? This is pretty real life here. But I'm going to say that's probably not as dark as a 4, right? That's more like along the 2 and 3 lines there. So I think we need to turn that up a little bit. That's not a totally linear scale of the setting versus the color of the toast. So we're going to look for our second order effects. Maybe the roommates are angry. Okay, we need to address that. We need to figure out what to do. Okay, so act or adjust. If the toast is correct, we're going to codify those changes. We're going to create our SOPs. We're going to ensure that we can have continued success. If it isn't correct, make changes. So here we've got our knob. Let's say that it was correct. Let's say that we're happy with that. Maybe we put a label on it, Brad's Toast. Okay, so this is exactly where we want to have it. And then we can put different labels for different roommates. Maybe we put a Brad's Bagel setting on it. Now we know, right? Now we've made a consistent toast. All right, the last thing I want to talk about with PDCA and problem solving, these are probably 4 of the more common problem solving methodologies, but they are not all of the problem solving methodologies. PDCA, PDSA is the simplest. It has the least letters, right? The least steps. DMAIC is very common if you're familiar with Six Sigma. A lot of companies use A3. It doesn't really matter. What I recommend is every organization just picks one. It doesn't matter which one, but it picks one and it moves forward from there. If you're using DMAIC, then DMAIC is fine. If you're using PDCA, it also works well. But you'll see they're all much the same. Some of them are just a little more specific on the steps. That's all I've got for this video. Have a great day.